Okay, so we will continue now with the previous topic because there were some issues when I have to stop the recording. So, as we said before, we are now going to sketch the graph of the inverse function, which I already said it's gonna be logarithmic function. And we will start with the point 1, 0, which is here, if this one is number 1. So for number 2, the value is 1, so this is our next point. For number 4, and please have a look, I'm not gonna sketch the number 3, but directly number 4, it's gonna be number 2. So it's here, then we need number 8, which is approximately here, and its value is 3, which is somewhere here. Now, if we want to sketch half, then we go to -1, which is here, and if we want to sketch again half of 1/2, we go to -2, which is here. So now it's really simple and easy to sketch the graph of such a function, and the graph will, okay, this is a little bit tricky, and the graph will pass through all these points and will look something like this. You can very easily find out that the next value or the next point will be somewhere here, which is 16, and in the meantime it will grow only to number 4, so not a lot. You can see that our function behaves something like this. Okay, now this is what we do graphically, and just let me tell you now, the graph of this function, inverse function, which is logarithmic function, is this kind of line. Now let me explain how can we find let's say how the function is defined with special word. And before I start, let me just show you that the word logarithm, we can say that it consists like of two parts. The first is log and then a rhythm. This is something which you will understand a little bit later. Before we do everything analytically, let me say that if we talk about the exponential function, it is defined with the equation y equals a to the power of x, where a is base, x is exponent or power, if you want to. Maybe sometimes you will hear that this is called also index. So if we want to define, and you already know, if we want to define the inverse function, the procedure we do is that we change x and y in our equation, so it will become like x is equal a to the power of y. Now the question is, what do we do and how do we do and why do we do, so that we get really the definition of logarithmic function. Let me just take this one so that I have enough space for explanation and that you will see everything on the screen. So I need the space here. Let's do it here, because this is like maybe not explaining why, but explaining that we do the general thing for the functions we were looking for its inverses already. The first function we were talking about, the inverse function we met together, was for example quadratic function, which is defined by the equation y equals x squared, and then to find its inverse we just did x equals y squared, and now we did the inverse operation, which we already know and we knew before. It's called square root, and this was the way we found that our new function or inverse function was defined by the equation y equals square root of x. Okay, then we were talking about the properties of the square root of x function and so on and so forth, but this was the main idea behind how did we find the inverse function. For example, we did the same thing for y equals x cubed, and to find the inverse of the function we did the same procedure. We changed the x and y values, so x was equal to y to the third power or cubed, and then we did again the third root of both sides, and our function inverse was then defined like y equals third root of x. Okay. In case of logarithmic function, it is, I don't want to say it's harder, but this is some, we know how to calculate the square root or third root of any number, because we were talking about it during our previous studies, and today we have the function which is the exponential function, and it is defined as, and let me just write it with the numbers, 2 to the power of x. We know how to find already the inverse, which is gonna be like x is equal 2 to the power of y. And here is this analogy with finding the inverse of the square root or x cubed. But in this case, we say that we do a logarithm of both sides of this equation, which is denoted like log base 2. Okay, during the next studies you will understand maybe more deeply how this works and how can we do such a thing when we do the calculations. But let me do it now like this. So log, and as we did log, this is the argument of this log base 2 of x is equal. Now we will come to something like this, log 2 of 2 to the power of y. And here comes the tricky thing you won't understand right now, but this expression can be replaced, and it represents, and if you would calculate or ask any, let's say, very clever tool, the evaluation of this function is equal to y. So basically log base 2 of 2 to the power of y is equal y. This is what you have to just respect for now. Nothing else can be done here, just take it as a fact. Okay, so if we apply this on both sides, we will come to the definition of the inverse function, and the definition says y is equal log base 2 of x. So this is our inverse function to the exponential function here. Okay, so I think this is all I wanted to say concerning the functions, how we find graphically and algebraically. There is one more thing I wanted to say. We already know that if we want to sketch the inverse function of any function, the inverse function is symmetric with the respect of the line y equals x, which basically means that you take any number from your function and you just do the symmetry, and you will find all the points of the inverse function. And as you can see, this, if we do so, especially this key point of the exponential is changing its coordinates from 0, 1 to 1, 0, and so on and so forth. So if you really would do it precisely, you will get the graph of the inverse function to the exponential function, which is really the same curve as we got during our operation when we just changed the coordinates of all the points of the given function, in this case exponential. So the exponential function in the logarithmic function in general is defined like, or by this equation. F is defined by equation y equals log, and what can you see here? This is our base and this is our unknown, and y is the value of the function. So as I said, the base, so this is this small a is like subscript, which says what is the base of the log function, and you simply read this one as log or logarithm base a of x equals y. Okay, so this is a kind of definition of a logarithm function. Now, as I said, I want to explain a little bit more what's going on over there, and how can you, for example, read the information from the table, which, for example, when we applied the definition we just came to, this ordered pair can be calculated like this, so that log base 2 of 8 is equal to 3. Okay, and now I'm gonna try to explain in more details how do we do and what's behind this. Okay, but to do so I will need some more space here, so let me just clean my screen, and let's see how can we do. Okay, so we'll be working with the exponentials and then with the logarithms. We already know that 2 to the power of 4 is equal to 16, okay? In this numerical expression, we know that number 2 is our base, which can be also called like growth rate. Okay, it says that we double each time the previous value, and we can calculate the value. If we do so, then we said that number 4 is called exponent, or if you want power. But basically what this says is how many times do I double number 2, okay? And number 16, just this is our final result, okay? The final result, okay? So basically 2 to the power of 4, how many times do I have to double number 2 so that I will get numbers? If I do it 4 times, I will get number 16. Basically the same thing can be asked and seen when we do 2 to the power of 0. We already know that the result is 1, but let's have a look on this from the perspective of time. So the main question is, how many times did I grow? How many times? And of course 0, so it means I remained the same, or the number remained the same, so result is 1. Okay, so the result is 1 because you are the same size as you were before. Okay, let's have a look what 2 to the power of negative 1 is equal to, and the question is if you are now the size you are and you go one step backwards, what then your high, or what is the value you had if you go one step backwards? Of course it's gonna be half of your size, or it's gonna be half. Okay, so then again, if we want to apply the logarithm thing and read the stuff in the manner of this explanation, we now know already that from this line, okay, we can write the inverse function, which says log base 2 of 16 is equal to, and we already know what the value is, that it is 4. But the main question here is, as our growth rate is 2, and the question now is, how long did we do grow, or how many times did we double number 2 to get number 16? And of course the answer is, we did it like 4 times. Okay, again the same example, log base 2 of 1 is equal to, so if how many times did we double number 2 to get the same size? Of course we did nothing, so the result is 0. Okay, so log base 2 of 1 is 0, and we can do the same thing. Log base 2 of 1 over 2 is equal to, we already know that this is negative 1, but how many times, or when was it when I was half size? Yes, it was 1 step backwards, so this is the result of log base 2 of 1/2. Okay, I'm pretty sure this is like 3 or 2 points of view for the logarithms, but the main idea is, or the main conclusion behind all this is, that there exists a logarithmic function which is defined basically like y equals log base a of x is equal to y, and what it basically means, and the question we are asking, how many times did we, let's say, grow with a, how many times did we grow with a to get x? Okay, the next explanation of the logarithm, or the next way how to understand this, could be that a log is always equal to exponent. Okay, how is it so? If you have again look on the example, log base 2 of 16 is equal 4, it basically means 2 to the power of what is equal to 16. Okay, so you work vice versa, 4 to the power of what is equal to 16. So 2 to the power of 4 is equal to 16. Okay, if you would do the same procedure, for example, log base 3 of 27 is equal to what, then you ask yourself, 3 to the power of what is equal to 27? And of course the answer is 3, because 3 times 3 is 9 and times 3 is 27. Okay, so log is inverse, or logarithmic function is inverse function of the exponential function. The graph of the logarithmic function is represented by a curve like this, and I will come back later to the explanation and to the properties of logarithmic function, and we will find the connection with the exponential function based on the bases of both functions. Okay, I think that's all for today. I think that maybe you have to watch this video more than one time to understand what is behind all this logic, and if you would have any questions, feel free to ask. Okay, thanks, bye.